Okay, welcome to Unit 4, Day 1 notes. So this is Day 1's worth of notes. We're going to call this 4.1. Okay? 4.1. I am out of town. It is Monday / Tuesday, October 17th and 18th. I need you to watch the whole video. It is going to be a long one. This is going to be a rather, somewhat intense unit. But I believe that if you take the notes and you do the homework, you're going to be successful. Okay? You've got to have some confidence. All right? So what I write, you write. And when you're doing the homework, refer to the notes. That's the whole reason why we're doing them. All right? Refer to the notes. This video is going to be a little bit long, so please be patient with it. If you halfway through need to pause it, get up and do a little dance or something just to get yourself refocused, then make sure you're able to do that. Pause it, stretch, and then come right back and get going. All right, we're a minute in. This video is going to be long enough anyway, so let's get right to it. All right, the first part of this, I want to explain, kind of back up and say, let's get started, and then I stop all of a sudden. This unit, we're going to start talking about triangle congruence. All right, so we're going to figure out how we can say one triangle is congruent to another and all that. So that's where we're going. All right, so we're going to talk a lot about triangles. This unit's all about them. All right, so the first one, a triangle, is a polygon with 3 sides. It is also the smallest polygon there is. So it's the smallest one. Smallest polygon. Okay? I just need you to know that, other than just having that sheer knowledge, that our triangle is our smallest polygon. Okay? The second part, it says triangle classification. And we're going to talk about angles. And what angles means, that is, what do the different angles of the triangles mean? What are they trying to tell us with it? Because every angle in a triangle, or the group of them together, or just one or two of them or whatnot, they're all telling us something, okay? They're all giving us pieces of information that we can use. The first one is equal angular. Equal angular, that means 3 congruent angles. That means I'm going to have a triangle where all 3 angles are going to be congruent. So all 3 angles are congruent. And remember, congruence and equals, basically the same thing. Congruence to equals equals to congruence, right? So, the second one, through 3 acute angles. Through 3 acute angles. This is going to tell you that all 3 angles inside a triangle. So if I have a triangle, I'm going to draw one here, right there. That all 3 angles are less than 90 degrees. So all 3 angles less than 90 degrees. So all 3 angles are less than 90 degrees. Because remember, acute means less than 90. A right triangle is going to have 1 right angle in it. So I have a triangle like this. Remember, if I have a right angle, you're always going to see the box in the corner. The box in the corner. So if I have a right angle, I'm going to have a box in there. The other 2 angles have to be less than 90 degrees. We'll get to that here in a second and tell you why. And then the last one is obtuse. Obtuse is going to have 1 angle greater than 90. So if I draw like that, this angle here, right here, is greater than 90 degrees. It's greater than 90 degrees, okay? So 1 obtuse angle, or one angle greater than 90 degrees. And that's greater than. So 1 angle greater than 90 degrees is an obtuse triangle. All right, Let's talk about the sides. The sides, equilateral. Equilateral basically says that all three sides are going to be congruent, which means all three sides are equal. Equal. So you would have a triangle like this. Hopefully I drew it as close to there, and you would see this. These little tick marks. Remember, the tick marks tell us that these sides are all the same. Just like in an angle, the tick marks inside, all three of those tell me that those angles are congruent. These tick marks on this triangle tells me that all three sides are the same. Okay? Are the same. Isosceles, at least two congruent sides. So you would have a triangle like this, and the tick marks would look like this. Okay? This side would be a little bit longer, a little bit shorter, but the other two, okay? The other two, the sides, the legs of that triangle, are going to be congruent. And last but not least is scalene, which means that no sides are congruent. No sides. So I may have a short, long. No sides are congruent. So no sides are equal or congruent. Okay? So that's the beginning of our vocab for this. Remember, when doing the homework, refer to the notes. All right, let's move on. It says classify the triangle by its sides and angles. You must always be as specific as possible. And let me write in these things right here. This one says 58 degrees. This one is 65 degrees. And this one is 57 degrees. Okay? And it says classify the triangles by its sides and angles. You must always be as specific as possible. Well, I noticed that in looking at this, all three of these are less than 90 degrees. They're less than 90 degrees. So I know that it is an acute triangle. It is acute because all three sides are less than 90 degrees. And then the other thing I know that you're going to find out later on, and that is the sides or the legs of triangles go in relation to the angle. So the smaller the angle, the smaller the side. The bigger the angle, the bigger the side. So I know when I have three angles that are not congruent, then that means none of the sides are congruent. So this means there's also a scalene triangle. So this is an acute scalene triangle. All right, the second one. This angle in here, we could see it, but it does say 130 degrees. So as I look at this, the first thing I should know is this is an obtuse triangle. And as I wrote that little thing, I kind of screwed it over something. I want you to be able to see it, 130 degrees. There's also tick marks. And there's two tick marks. One right there and one right there. Well, those tick marks tell me that the two sides are the same and they are congruent. So if they're congruent and I have two sides that are, then this is an obtuse isosceles triangle. So this is an obtuse isosceles triangle. All right, and the third one. These all in here say 60 degrees. So all three of those angles, and I'm just going to write it up here, all three of those are 60 degree angles. When I just kind of talked about in the first example of this. The sides correlate with the sides of the angles, right? So if the sides, if the angles are all the same, then all the sides have to be the same. So this is going to be an equal angular. And since it's equilateral, it is also equilateral. 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 Remember, all three sides, if they are the same, that all three sides are congruent, then it's an equilateral triangle. The measure of the angles has a direct relationship with the sides of the triangle as well. Okay? Let's move on. Explain why the triangle is a scalene right triangle. Well, if I look at it, I've got a side of 6, a side of 8, and a side of 10. Okay, well, none of the sides match, right? I've got a 6, an 8, and a 10. So it has to be scalene because none of the sides are the same, right? And then I know that this has a box in it. This box is universal. It tells me it's a right angle. So I can go ahead and fill it out. Explain why the triangle is a scalene right triangle. Well, it's a right triangle because, why? It has a right angle. It's a right triangle because it has a right angle. That's pretty self-explanatory. And the next one is it's scalene because all sides are not congruent. None of the sides are congruent, right? None of the sides are congruent. No side is congruent. All right? So you're going to have to look at some triangles today and determine, is it acute? Is it right? Is it obtuse? And then the same thing, is it isosceles, scalene, or right? Okay? Those are the things we're going to use. All right. Moving on. Classify the triangle by its sides and angles. Classify by its sides and angle. Well, the first one, I look at it and I see 4 meters by 4 meters by 4 meters. Remember, if all three sides are the same, then the angles are the same. So this is going to be an equilateral, and we can see that directly. All the sides are the same, right? So equilateral, but all three angles are the same as well. So it's an equiangular, equilateral and equiangular triangle. All right? The next one, I've got 5 kilometers, 10 kilometers, and 7 kilometers. As I look at this, there's no measurements in there for angles, but I look at it and I know it's not a right angle. I know it's not right because there's no box in there. Visually, I know that it's above 90 degrees, so it makes it an obtuse. I'll do this in red. Obtuse, right? Because the angle in here is above 90 degrees, and it's also going to be scalene. It's going to be scalene. No sides are the same. No sides are congruent. So it has to be a scalene as well. All right, and last but not least, I have a 60, a 45, and a 75. Well, the first thing I notice about this is all three angles, I'm not given the sides at all, right? I'm not given any sides, I'm just given angles. Well, none of the angles are above 90 degrees. They're all less than. So this is an acute triangle. Every angle less than 90. And then none of the sides are going to match because none of the angles match. So this is also going to be a scalene. Scalene. All right. Hopefully you're keeping up with me. If not, make sure you pause. Make sure you pause it and do all that, okay? We're about 15 minutes in, about 14 and a half minutes in. We got several more to go, okay? Let's get one more. Let's get a couple more of these. Classify the triangles by its sides and angles. Well, look at this one. I got 6 centimeters, 6 centimeters, 3 centimeters. Well, I know that I've got 2 sides going to be the same, which means I'm going to have 2 angles the same, right? And there's no big side, so I'm looking at that and I'm going to go, that's going to be an acute. There's no angle is going to be greater than 90, and it's going to be an isosceles. Isosceles. The next one, I have a right angle in there, so I know it's a right triangle. Right triangle. And then also, I've got a 60, a 30, and a 90, so none of the sides are going to match, so it's also going to be a scalene. No sides will match. And then the third one, I've got a 100, a 40, and a 40. Well, I've got two angles that are the same, so it means two of the sides are going to be the same, so that tells me an isosceles. I have 100 degrees in there, so I know obtuse, greater than 90, 100 is, and two the same, which means this is going to be isosceles. Isosceles. All right, the last one. Take a look at it yourself real quick. See if you can do it. I'll give you about 5 seconds. You could pause it. 1,000, 2 1,000, 3 1,000. All right, hopefully you pause it. Here we go. Hopefully you've done it on your own. I look at this. I got a 60, a 60, and a 60. Well, I know this is equal angular, because all of the angles match. But I also know that since it's 60, 60, and 60, all the sides are going to match. So this is also going to be equilateral. Equilateral. All right. Hopefully you're catching on. You'll be able to get some more practice here. Okay? Let's keep moving. All right. Find the value of x. So now we're going to add some algebra into this. I know it's one of those things that you don't necessarily like, but I'm going to remind you of something. I know you've been taught this before, but I just need to remind you. All three angles inside a triangle add up to equal 180 degrees. So all three angles add. Don't like it when I do that. Add up to equal 180. So I know that when I look at angles inside a triangle, they all have to add up to 180. It makes it nice and easy mathematically when we start doing these. So I look at this one. I've got a 35, and I'll write this, make it a little bit clearer. This is 35 degrees. I have an X right here. I don't know this one. And I have a box. Well, the box tells me 90 degrees. So I know that I can do this one of two different ways. One of two different ways. I can go ahead and say 90 plus 35 plus X equals 180. Well, I know that 90 plus 135 is 125 plus X equals 180. Subtract 125 from both sides, and X is going to be equal to 55. X is equal to 55. That is one way. Adding them all up, setting it equal to 180. Here's another way that some of you may like better, but remember, it's not always going to work because sometimes you're going to have more than one variable or more than one X, and it isn't always going to work. But it is when I just have numbers. And that is, I go 180 degrees is my total, right? I'm going to subtract 90 from it, subtract 35, and that's going to be equal to X. This is how we would do it mentally in our head. We would take 180 minus 90 minus 35. Well, 180 minus 90 minus 35 is 55. That's how we put it into a calculator. That works as well. Okay, so if you can see it, you don't have to set it up algebraically. You could literally go 180 minus 90 minus 35, give me x. 55. That would work, okay? Just remember, when we start getting multiple variables in there, or 2x's and 4x's, or x plus 10 and all that, it doesn't work as easy that way. All right. Moving on. Find the value of x. X, I have 125, 20, and x. So 125, 20, and I have an x. Well, let's do it the way I logically would think about this, and that is 125 plus 20 plus x would equal 180. Well, that becomes 145 plus x equals 180. Subtract 145, subtract 145, x is going to be equal to 35. Once again, you could have done it 180 minus 125 minus 20 equals x. Put it in the calculator, got x equals 35. It would work both ways. If you want to simply put it in the calculator and go, hey, if I know all three angles add up to 180, and I subtract 125 off of it and subtract 20 off of it, I know that that has to be 35. All right. Hopefully you're picking up on that. Moving on. Find the value of x. Find the value of x. This is where that whole just putting in the calculator doesn't always work, so you have to have that other one, okay? The other one that I keep showing you. I have an x, and a box. An x and an x in a box, okay? So this is an x, this is an x. I know that they still add up to 180 degrees. They're still 180. So I know that x plus 90 equals to 180. Well, what's x plus x? And if you think x squared, please stop right now. Remember, we're not multiplying, we're adding. So 1x plus 1x is 2x plus 90 equals 180. Subtract by 90 equals 2x equals 90. Divide by 2, x is going to be equal to 45 degrees. So I know that x is going to be equal to 45. And that makes sense. 45 plus 45 is 90. Plus 90 is 180. That makes total logical sense. Okay? All right. Moving on. Find the value of y. Well, I've got a 70 and an 88, and I've got a y on the outside of the triangle. Outside of the triangle. Well, what don't I know yet? Well, I don't know y, and I got to find it, right? But I also don't know the value of this angle. But can I find it? I can. And then we're going to use something that we used in the last unit and in the first unit to be able to find y here in just a second. But I can find this angle really easy. 180 minus 70 minus 88 equals this unknown angle, which I'm going to label x, okay? So I'm just going to label it x. It's my unknown, right? It's my unknown. Let me grab my calculator. I have 180 minus 70 minus 88. That gives me 22. So I know that 22 is equal to, not 22x, 22 is equal to x. So I know that x is equal to 22. And I'm going to end up writing it here now. So 22. Okay? I have to find y. Well, let's think about what the relationship is to 22 and y. 22 and y. Well, remember, what's a linear pair? linear pair is a pair of angles, two angles, that add up to form a straight line, which means a straight line has the degrees of 180 degrees. One of the reasons why we now have it in our third unit, so 3 out of 4 units, we've had linear pair. This is how important this is. You have to understand that this angle plus this angle added together is 180 degrees. So I can do this one of two different ways again. Ready? Here's the first one. 22 plus y equals 180. Subtract 22. And y is going to be equal to, what is 180 minus 22? It is 158. 158 degrees. Okay? That's one way to do it. Right? I could also say 180 minus 22 happens to be equal to y. So this would be 58 equals to y. We could do it either way, okay? Just remember, when we get multiple variables or multiple, an x plus 10, 2x minus 9, all of that, we need to set it up algebraically. But when I'm just having a number, which is 22 in this case, I can subtract it from 180 to find out what y is. All right. Hopefully that makes sense to you. Remember, linear pair, two angles add up to form a straight line. And you can see it visually because they do form a straight line. If this little hypotenuse is not there, then this is a straight line. All right, moving on. We just got a couple more, about 3 more, okay? I need to find the value of y. We got a y here, outside. It's outside. I've got a box, this box, which tells me that this angle is 90, right? And I don't have any other piece of information. But let's think about it a second. This is 90 degrees, right? And this is forms a linear pair. So 180 minus 90 equals y. Well, what's 180 minus 90? 90. And does that not make sense that if I have a right angle on one side of a line, wouldn't I have a right angle on the other side of it if it's a straight line? I would. Okay? Number 13. I'm not sure why we have exclamation points instead of degrees on here. I'm not sure why it's popped up that way. But I have 42 degrees here. I have 20 degrees here. And this is y degrees on the outside. Once again, I have a y on the outside, so I know I'm going to use linear pair here in a second, right? Because I'm looking for the angle on the outside. First, I got to find the angle here, so I'm going to label it x. X. So I know that 180 minus 42 minus 20 equals x. Well, what's 180 minus 42 minus 20? 180 minus 42 minus 20 is 118. 118. So, find my pen. 118 equals x. So I know that now this one is 118. Now I know I can find y by going 180 minus 118 equals y. I'm substituting in this 118 in for x. 180 minus 18 is 62. So 62 equals y. So I know that y is 62 degrees. All right. Any questions, please feel free to ask. I'll be back on Wednesday, Thursday. We'll make sure we're going to go over this for you. We're 29 minutes in. I think we have 2 more examples to go. Okay? Here we go. Find the measure of the numbered angles. I'm going to find the measure of angle 1. This one is 30 degrees. This one is a box which tells me it's what? That's right, it's 90 degrees. The box tells me it's 90 degrees. So I could go 90 plus 30 plus the angle 1 equals 180 degrees, right? 90 plus 30 is 120. I want to find the measure of angle 1, and it's all set equal to 180 degrees. Subtract 120. Angle 1 equals 60 degrees. So I know that angle 1 is 60 degrees. Okay? 60 degrees. Alright. We do know that if you like the other method better, and this is your second chance, I know I could have gone 180 minus 90 minus 30 equals angle 1. And that becomes 60 equals the measure of angle 1. Just remember, that's the way I would do it in a calculator, and it's pretty easy, okay? This is when the math gets a little bit harder, when we get multiple variables and variables in addition to numbers and expressions and all that. That's the way we're going to have to do it. All right, your last example. Your last one. I've got the measure. I need to find the measure of angle 1, angle 2, and angle 3. Holy cow, here we go. Find the measures. Angles 1, 2, and 3. All right. Well, the first thing is that I know I have 70 degrees here, right? I have 30 degrees here, and I have a box here which is 90. Well, let's find the measure of angle 1. That's going to be the easiest first, right? So I have 180 minus 30 minus 90 equals the measure of angle 1. Well, 180 minus 30 minus 90 is going to be 60. So I know that angle 1 is equal to 60 degrees. Okay, so I've got that. I have that one. You're maybe wondering, well, how are you going to find two different angles inside one? You don't have enough information. But I do, because we're going to pull in a concept that we looked at in the last unit. Remember the term vertical angles? Vertical angles. Angles on the opposite side of the vertex have to be what? Congruent. And congruent means equals, right? So I know that the measurement of angle 2 has to be 30 degrees. Has to be. Because angles 2 and 30 degrees, those two angles are formed. They are vertical angles. They're formed by the same vertex or on opposite sides of that vertex. So they are the same. They are equal. They are congruent. Okay? So I now know that angle 2 is 30 degrees. So I can find angle 3 pretty easily. 180 minus 70 minus 30 equals angle number 3. Well, 180 minus 70 minus 30 is 80. So angle 3 is equal to 80 degrees. Alright, so we found the measure of angle 2, found the measure of angle 1, found the measure of angle 3. Hopefully you have paid attention. You've written what I've written. We're 34 minutes into it. You have a 90-minute day. You have plenty of time to get everything done. Use your notes when doing the homework, please. Have a great day. We'll see you on Wednesday/Thursday.